Welcome to the Explainer. Today, we're exploring some really powerful techniques for finding patterns in data that, the data doesn't even tell you it has. Okay, let's dive right in. So imagine you've got this mountain of data. Maybe it's user activity, maybe it's customer info, but here's the catch. It is completely unlabeled. How do you even start to make sense of it all? I mean, it's a super common problem, right? You just know there are valuable insights hiding in there, but you don't have a clear target to aim for. And that's where this whole idea, this field of unsupervised learning, comes into play. See, unlike other methods that need pre-labeled examples to work, this branch of machine learning is all about pure, unadulterated discovery. Okay, so here's the key difference, and it's all about the data you start with. With supervised learning, you have a target. The data has labels, it has the correct answers, so the model can, check its work. But in unsupervised learning, nope, no labels. The entire goal is to let the algorithm find the natural structure of the data all on its own.
And probably the most common task you'll see in unsupervised learning is something called clustering. So, what is that exactly? Well, it's actually a really intuitive idea.
Let's put it this way. Imagine you're planning a few meetups for users all across the city. You'd want to pick a few central spots that are convenient for everybody, right? Well, clustering is what helps you find those natural groupings in your user location data. It helps you find the center of each little local community. That makes total sense. But how does an algorithm actually decide where those groups are? Let's take a look at one of the most popular methods out there, k-means clustering. It's actually a pretty elegant and surprisingly simple way to get this done. So the k-means algorithm is what we call an iterative process. It doesn't get the answer right on the first try. First, it just picks k random points from your data to be the initial centers or means of your clusters. Just think of these as a first wild guess for where our meetup spots should be. All right, next up is the assignment step. The algorithm goes through every single user location one by one and calculates how far it is from each of those initial meetup spots. Whichever spot is closest, well, that's the group that user belongs to, for now. But here's the really clever part. Those initial guesses, they were just starting points. Now that everyone's been assigned to a group, the algorithm recalculates the true center of each of those brand new groups. Our meetup spots literally get dragged toward the real center of gravity of all the users assigned to them. And it just does this over and over and over again, assigning points to the closest center, then updating the centers based on the new groups. Points get shuffled around, the centers move, and this whole dance continues until eventually everything settles down and the assignments stop changing. At that point, you've found your final clusters. Okay, wait a minute. That brings up a huge question. The k and k-means, that's the number of clusters you want to find. So how in the world do you know how many clusters to pick in the first place? How many meetups should we even be planning for? Yeah, and picking the wrong number can really mess up your results. If you pick too few, you might lump totally different groups together. But if you pick too many, you might start splitting up groups that really belong together. So, thankfully, there are some tricks to help guide this decision. One of the go-to methods is to basically try a bunch of different Ks. You run the algorithm for, say, 2 clusters, then 3, then 4, and so on. And for each run, you measure the total error, which is just a fancy way of saying how far away, on average, the points are from their cluster centers. You want your clusters to be tight. Now, as you add more clusters, your error is always going to go down. But what you're really hunting for is that elbow point, that spot on the graph where it suddenly flattens out. That bend tells you that adding another cluster isn't really buying you much improvement. That's your sweet spot, a great indicator of the natural number of groups in your data. Okay, so k-means is awesome, but it's not the only game in town. There's another approach called hierarchical clustering, and it tackles that whole how many clusters problem in a totally different way. So get this, instead of guessing a number of clusters up front, this method starts at the absolute bottom. It assumes every single data point is its own tiny little cluster. So in our example, every single user starts out as their own group of 1. Then, step by step, it just looks for the 2 clusters that are closest to each other and merges them into one. So the 2 closest users get paired up first, then it finds the next closest pair, and so on, building up bigger and bigger clusters. And it keeps doing that, merging and merging, until everything is grouped into one giant supercluster. But the real magic here is what you get at the end. This beautiful tree-like structure that shows you the full hierarchy of how everything is related. You can then just look at it and decide where it makes the most sense to snip the tree to get the number of clusters you want. Now, this might all sound a bit abstract, but clustering has some seriously cool and sometimes surprising applications. For instance, you can use it to reduce the number of colors in an image. You just treat every single pixel as a data point in a 3D color space. Use k-means to find, let's say, 16 representative cluster colors, and then recolor every pixel with the average color of its cluster. Pretty neat, right? So from organizing meetups to recoloring images, clustering is an incredibly powerful tool for discovering that natural structure hidden deep within your data. It's all about letting the data itself tell you its story, revealing patterns you might never have even thought to look for. Hey, if you found this useful and it helped you see some new patterns, do us a favor and share this explainer with your network. And of course, subscribe so you don't miss the next one. Thanks so much for watching.